This question is taken from Olympiad 2024. There is a square grid circuit. Resistance of each wire between the two joining is R, and the value of R is given. It is 1 by root 3 ohm, and a resistance less wire is connecting through the ends of the square. This is resistance less wire, and this resistance is R, this is R, this is R. Every wire has its resistance R. You have to find the resistance between the equivalent resistance between the terminals X and Y. The answer is also given. It is 7 root 3 by 40 ohm. So how to solve? This question is 10th level question, but I think this is quite difficult for 10th standard. You can solve the question using Kirchhoff's law, but that process will be lengthy. So I will solve the problem through method of symmetry. There is a folding symmetry exists in this circuit. How can you solve this process? By only using method of symmetry. If this point is X, this is resistance less, this point is also X. How? If there is a resistance is R, the point is A, this point is B. If current is passing or flowing through point A to B is I, then Ohm's law says VA minus VB equal to IR. If resistance is 0, then VA equal to VB. So you can call the 2 points A and B as a single point A or B. Okay, this point is A and this point is also B. Now apply the same thing. This point is X, this point is X, this point is also X because this is resistance less. This point is also X. Now you have to find the equivalent resistance between X and Y. So it is same as X and Y. It is same as X and Y. Same as X and Y. Now take a battery and send current through the point I, X. Let's the current is I and it is leaving through the point Y. The same current is leaving. Now if is current entering this point, so it is dividing in two part, dividing in two part, dividing in two part, dividing in two part. So there is a symmetry. This is this current. If this current is I, this current is I, this current is I, this current is I. So all total, let's say there is a 8I current is entering and 8I current is leaving. So this current is I, this current is also I, this current is I, this current is I. All the points are identical, na? This current is I, this current is also I, this current is I, and this is also I. All the points are identical. That's why I am doing this. If I take this I, then it will be I by 8, I by 8, I by, that is no necessary for that. So now look at that points. These points identical. These 2 points are identical. These 2 points are identical. These 2 points are identical. So can you find the identical points? Okay, no difference between these points and these points. No difference. Same voltage drop. So we can fold the circuit to this line. You can join the points which have the same potential. So fold the circuit. Okay, fold the circuit, and you don't need this wire now. You can remove this. You can remove this because it has no resistance. You can remove. Now fold the circuit. All the resistances in that part will become half. Okay, if you fold, then this part will superimpose to this part. This has resistance R, this has resistance R, X, and let's say the point is X1, this point is also X1. So there is a resistance between X and X1, and there is another resistance between X and X1, and you are superimposing. So the resistance of that part will become half. So if this is R, R is given, then now resistance of this wire is R by 2. Okay, it is R by 2. Now remove all the part except this line. This is not superimposed to anywhere, so these are resistance R, these are resistance R, these are resistance R, these are resistance R, but this wire has resistance now R by 2 after folding. So I am removing this part. Okay, so this is R by 2, 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 all are R by 2, but this is R, this is R, this is R, this is R. Now you have to find the another symmetry. Can you find some another symmetry? This point is X, this point is X, this point is Y. And what is the difference between this point and this point? No difference. This is X1. If this is X1, then this point is also X1. Okay. If this point is X2, then this point is also X2. No difference. Look X and Y. Look X and Y. No difference between these two parts. So there is another folding symmetry exists. Now fold the circuit. So except these where this is R by 2, this is R by 2, except this part, all the wire now become, the resistance of wire become half. So this is R by 2, 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 these all resistance has R by 2. If I fold, then this is R by 4, 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 this is R by 2, this is R by 2. Okay, so I am removing. This is R by 2, now this is R by 4, and I am removing this part. This is R by 2, I am folding with it, so this is R by 4. I am removing this part. This is R by 2, this is R by 2, I am folding, so this is R by 4. So like this, I am removing all the parts. This is R by 2, this is not R by 4, this is R by 2, this is R by 2, I am folding this. Okay, R and R parallel connection, so it is R by 2. Removing this part. So this is R by 2 and covering all. Okay, like this. This is your entering point now, X. Now current is entering through the point X and it is leaving through the point Y. This point is Y. Now look at the symmetry. R by 4, R by 2. Sorry, it is R by 4. Now you can check further symmetry. R by 4, R by 4, R by 2, R by 2 from X to Y. Now R by 4, R by 4, R by 2, R by 2. Same symmetry. Okay, R by 4, R by 4, R by 4, R by 2, R by 4, R by 4, R by 4, R by 2. Same symmetry. So you can fold the circuit like that. Again, you can fold the symmetry. Okay, this point is identical to this point. This point is identical to this point. So these 2 points have the same potential. So if the 2 points have same potential, then why 2 points is to be considered? Take a single point. So fold the circuit again. If you fold, then this part and this part will be superimposed to each other, and the resistance of this part will become R by 8. So it is R by 8 half parallel connection, and you should remove this part also. This is R by 4. So this is R by, this is actually series connection. So you can you can take a single resistance R by 4 and R by 2, replacing these 2 parts by 3R by 4. So remove this part and take a single resistance of the value 3R by 4. Okay, this is also 3R by 4. This is series connection. So this is 3R by 4. Now fold. So what will be this resistance? 3R by 8. Now remove this part. Okay, this is r by 4, this is r by 4, so this is r by 8. This is r by 4, this is r by 4, this will superimpose to this, so this is r by 8. This is r by 2, this is r by 2, so remove this part and this become r by 4. Okay, now you can see it is very simple now. Current is entering and current is leaving. So this is 3r by 8, this is r by 8 and r by 8, so these two becomes series connection, this is series connection, current is same, so r by 4, r by 8 plus r by 8, that is equal to r by 4. Now I am redrawing the circuit. This is your X point, this resistance is r by 8, so this is r by 8, this is 3r by 8 and this is r by 4, 3r by 8 and this is r by 4 and this is r by 4, so this is r by 4 and this point is y. Now you have to find the equivalent resistance between x and y. This is the parallel connection, so what will be the result? This part, 3r by 8 into r by 4 divided by 3r by 8 plus r by 4, r1 r2 by r1 plus r2, so it is 3r by 20. Okay, now replace this part by 3r by 20, replace this part by 3r by 20. Now what will be the result? The equivalent resistance between x and y equal to r by 8 plus 3r by 20 plus r by 4. This is series connection, so this will become 21r by 40, 21r by 40. Okay, now put the value of r, 21 and 40, and the value of r is given, it is 1 by root 3 ohm, it is 1 by root 3 ohm. So this 21 can be written as 7 into 3, 7 into 3, so this is root 3, so it is 7 root 3 by 40 ohm. Okay, this is the answer, 7 root 3 by 40. Okay, bye.